All right, so let's take a look at this question. I'll go through 4 versions, one for each quadrant where the angle will lie. So if we look at the first one, it's asking you to distinguish between the red and the blue arc. So you can kind of see here I'm hovering over the red point, and here I'm hovering over the blue point. So the red point is going to just be the angle. So what I want to do to set the red point is just to count this fractional unit of pi. Well, pi radians is 180 degrees, so it's this semicircle, half a circle. So I'm going to cut that into sixths. Well, each of these markings, here's 1/6, 2/6, 3, 4/6, 5/6, 6/6. So if we set this, we're going to set it to the first. That represents 30 degrees or 1/6 of this pi rotation. The second asks us to set the reference angle. Well, the reference angle is going to connect the end point of the angle, the terminal side of that angle, so this point right here, back to the x-axis. And so you're simply going to draw that in with your blue arc. So one side of the blue is always going to be on the x-axis here or the x-axis over here, depending on which quadrant. So this is our angle, and if you count back, it's 1 pi over 6 to get back down to the x-axis, and so that is our reference angle as well. We can submit and we verify that's the correct answer. Okay, if we go to second problem, and here if we look at this second problem, now we have 11 pi over 12. So now it's in terms of fractional units of twelfths of pi. So that means we're going to cut this 1/6 in half. So here's 1/12, 2/12 is 1/6, 3/12 is 1/4, 4/12, 5/12, 6, 7, 8, 9, 10, 11/12 is going to be right in this halfway between this tick and the x-axis. So when I set my angle, the red angle, I'm going to go halfway between this tick mark and the x-axis. So that's approximately 11 pi over 12. So my reference angle is going to be from this terminal side all the way to the closest, or the x-axis in that quadrant. So here's my angle from that terminal side all the way to the x-axis, and you can see the reference angle is always going to be acute, less than 90 degrees. So this is 1 pi over 12 rotation to get back to the x-axis, and so that is the reference angle. Again, I can check it and verify that those are correct. And if I go to the next example here, 7 pi over 6, again, if we're counting in terms of sixths, so here's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5, 6, and it's going to rotate past and be 7 pi over 6 all the way to this tick mark. So when I set my red angle, it's going to be that rotation of 1 pi over 6 beyond the semicircle. And so once again, when I set my reference angle, it's just the degree rotation to get from that terminal side back to the x-axis. So notice what I'm going to do. I'm going to place one end of my blue arc on the terminal side and one end on the x-axis, and that's going to give me the model. And I can just count backwards. I go 1 pi over 6, rotate back to get to the x-axis, and so that becomes my reference angle, 1 pi over 6. The direction isn't going to matter when you're talking about reference angles. It's always an acute angle. Okay, the last example would be one that falls in quadrant 4. So here's 19 pi over 12. So once again, we're cutting these into twelfths. So 1, 2, 3, 4, 5 halfway, 6, 7 halfway, 8, 9, 10, 11 halfway, 12 pi over 12. So we keep counting till we get to 19. So that's 12, 13, 14, 15, 16, 17, 18, 19 goes halfway past. So this right here is where the side or the angle is going to terminate. So if I take my red arc, I'm going to place that right halfway between the tick and the axis. So that's where 19 pi over 12 ends. And then my reference angle is going to be the acute rotation in the same quadrant from this terminal side all the way to the x-axis. So notice if I start to move this, it creates an arc that goes beyond 180 degrees. So I'm using the wrong point. So I need to grab this other point and rotate it back. right? And so this is the point that goes to the terminal side, and this is the point that will go to my x-axis. And notice again, this is an acute angle. It's an angle that just stays in that same quadrant. And if I wanted to count where it goes, so also I'm at 1 pi over, or I'm at 7 pi over 12, right? Coming back to this, so I have 1, 2, 3, 4, 5 pi over 12 left to get back to the x-axis. So 5 over 12 times pi, that's going to be my reference angle because I can count 1/12, 2/12, 3/12, 4/12. 5/12 is the rotation to get back to that x-axis. Once again, I can check my answer to verify that that is correct.